All right, these are Chapter 3, Section 1 notes. You do not need to write down these objectives. It's just telling you what you're going to do in this section. You also do not need to write down either one of these. You already have law of conservation of mass in your vocabulary, and chemical reaction was a vocab word in the last chapter. But we are going to talk about law of conservation of mass really quickly in a chemical reaction sense. Mass is neither created or destroyed, and we're going to apply that to a chemical reaction. Okay, so if you look at this chemical reaction, you've got PCl3 plus Cl2, that should be Cl, I'll change it, makes PCl5. If you have 10 grams of PCl3, and then you have 10 grams of Cl2, then you also have, if this here together equals 20, then it must also be 20 on this side. So here's our arrow, okay? On both sides of the arrow, the mass has to be the same, okay? Even if you have to add them together to make it the same. So the way the law of conservation of mass applies to a chemical reaction is basically that the mass should be equal on both sides. Okay, these two vocabulary words, you don't need to write them out of these notes because they're vocab words, but you do need to have a real grasp or understanding of what they are. Okay, so I'm going to do a little more with each one of these and show you what they are. Okay. For the law of definite proportions, what that means is if you have two formulas, in this case it's salt, sodium chloride, NaCl and NaCl. With this sample of sodium, I have 10 grams. With this sample, I have 100 grams. Okay? What it means is if I know that sodium is 40% of this compound, and that would mean that chlorine would make up 60% of the compound, then that's true no matter how much salt I have. Okay? So if I have 10 grams of salt, and I know those percentages, that would mean I would have 4 grams of this would be sodium, and 6 grams would be chlorine. Okay, with our other sample, again, if I know that this one is 40, and I know this one's 60, okay, that doesn't change if I have more salt, okay? If I have 100, I would just have, I would go the same percentage as 40 grams of Na would be made up of that sample of salt, and 60 grams of chlorine would be in that sample of salt. So law of definite proportions means that those percentages don't change, even if you have different amounts of the sample. Okay, for law of multiple proportions, it basically means that even though both of these compounds have carbon and oxygen in them, they can be very, very different. So the ratios in which they come together can change the whole, all the properties of the compound. So everybody knows carbon dioxide is a harmless gas, okay? But it's made up of carbon and oxygen. It's just in a 2-to-1 ratio, okay? Carbon monoxide is super dangerous. It's still, though, made up of carbon and oxygen. It's just in a 1-to-1 ratio. So the only thing changing either one of these is the ratio. They both have carbon and oxygen in them, but it makes them very, very different. Okay, and also both of those were vocab words, so you will have them in your vocabulary. So real quick, this is just another example that I like. It's just like with my carbon monoxide and carbon dioxide example. We have nitrogen monoxide here and nitrogen dioxide. And again, Just the addition of one oxygen atom makes them extremely different. This one is harmless, and this one is extremely poisonous. So that, again, is an example of the law of multiple proportions, and you will need examples. So make sure and write those down. Okay, the next thing you should write down is Dalton's atomic theory. You will need to have all the points of his theory. These are just the first three. There are more on the next slide. Okay, so all matter is composed of extremely small particles called atoms. Atoms of a given element are identical in size. Okay, now this was what he theorized a long time ago. It was just the original atomic theory. Atoms cannot be subdivided or created or destroyed. And these are the last 2 points to his theory. Atoms of different elements combine in simple whole number ratios to form compounds, and they combine, separate, or rearrange. Okay, so 5 points total. You will need to have Dalton's atomic theory in your notes. All right, the other thing you need in your notes is the modern atomic theory. John Dalton came up with that theory a long time ago. It has since been revised. Okay, so you're going to need to know which points of his theory were revised. So in this first bullet, not all aspects have been proven to be correct. These are the 2 bullets that have been proven not to be correct. But some of them remain unchanged even from a long time ago. So here are a couple of examples of points to that theory that are still true today. And you will want to know this as well. So also goes in your notes for your Friday quiz. All right, and that is the end of these notes.